Namaste, my dear brothers and sisters. The love and blessings of the Mother and Sri Aurobindo to all of you from Sri Aurobindo Ashram, Delhi branch. Topic: Are intestines large and small? Let me confess, this title I got from a book which I read long back, which was by a veterinary surgeon. The book was titled something like this: All Creatures Big and Small. And it had sort of brought out the beautiful aspects of animals, which we sometimes don't understand, how kind and gentle they can be, how friendly they can be if we are nice to them, and how much they understand, which we think they are not capable of, in spite of being mute. They may be mute, their language might be different from ours, but they do feel and understand quite a bit. So, our intestines, large and small. The Yes.03 course, of which today's session is a part, and all other activities under the Yes project are a part of the celebrations of the 150th birth anniversary of Sri Aurobindo and the 75th anniversary of independence. Gratitude to uh, Tortora and Grabowski for this beautiful book, Principles of Anatomy and Physiology, from which the anatomical pictures in this presentation have been mostly taken. This is what the inside of the abdomen looks like to a surgeon when he cuts it open. Uh, in fact, what is staring at him is not the stomach and the intestines as we might think, but a fatty uh, structure called the omentum. That is what can see. And if he reflects it, the greater omentum, you see. And then if he reflects it upwards, then what he finds it is the stomach here, the small intestine, and the large intestine, and finally the end of the large intestine. Broadly speaking, all this is the large intestine. Uh, the small intestine enters somewhere here, and the part below that entry is the cecum, and at the end of the cecum is the small little appendage, the appendix, which seems to have no real function in the human beings, although it had a lot of function in animals which live exclusively on plants and eat a lot of plants, and particularly difficult to digest plants like grasses, etc. The cows and the rabbits, they have a very highly functional appendix, but in human beings, it doesn't seem to be very necessary. It has lost that function, and we just have that rudiment left as a reminder of our evolutionary past. And then it continues into the large intestine, cecum upwards. This is the ascending colon because going up, transverse because it's horizontal, in the descending colon, and the sigmoid colon because of its S shape, and then the rectum, and finally the anal canal. Here's another view, a little different view of the same. The intestines have been brought out a bit from the abdomen to show the deeper structures. And here's a somewhat simplified view, leaving behind in the body only the stomach, the small intestine, and then this large intestine. Now, if we take a section that is cut across the intestine, of course, different parts will have some variations, but in general, the structure is something like this. This is the cavity, the open space, the hollow space, and this is the wall. Now, in fact, this entire thing is the wall, and to show different layers, it has been shown like this. The layer that is closest to this hollow part is a lining consisting of a single layer of cells, and this has a variety of cells, cells which secrete the digestive juices, cells which secrete mucus, which forms a sort of a lubricating lining. Here, cells which have immunological functions, which means sort of they can trap germs, etc. So all these are a part of this lining. And then we have uh, a thin muscular layer here, the muscularis mucosae. And then we have this submucosa, that is the layer below the mucosa. Mucosa is the inner lining. So below that is the submucosa. Below, sort of in a if sort of a figurative sense, if we look at it that way, otherwise the structures can be above or below. But anyway, we consider it below the mucosa, because if you start from here and keep going down, so it's under the mucosa, so it's submucosa. That is where we have packing material, the connective tissue, in which are the blood vessels, uh, the nerves, the arteries and the veins, red arteries, blue veins, which have been shown in section here, and these white structures, the nerves. And then we have the outer covering. But before that, we have these two important layers of muscle here. The These muscles are the circular muscles which encircle this. And these are longitudinal muscles which run along the length of the intestine. Now you can understand that these circular muscles, if they shrink, the lumen will become the cavity, this hollow part will become smaller. Whereas if these shrink, then the intestine, the length will be affected. It will sort of tend to fold up uh, instead of remaining straight. And both these are important for the different types of movements that take place in the stomach and the intestines to make sure that the food is well churned, and also food keeps getting propelled from one part of the intestine to the next. And uh, these are the sort of parts that really take part in the movements of the intestines. These little thin muscles do not take much part in that. Now, this is the first part of the small intestine called the duodenum, and what follows it is called the jejunum. And after that is the ileum. The duodenum, the jejunum, and the ileum all together form the small intestine. Duodenum is an extremely important part of the small intestine. Of course, all parts are important, but important in the sense that a lot happens in the duodenum. And we shall see all that happens here bit by bit. But from the structure itself here, you can make out that this is the part where the pancreas pours its digestive juices in, and this is the part where the bile, which has been manufactured by the liver and stored in the gallbladder, that comes down to the intestine through this tube, and that tube finally joins the tube coming from the pancreas, and the two together open into the duodenum. And since the pancreas is one of the most important digestive juices, which has enzymes for digesting carbohydrates, proteins, as well as fats, you can see that all the important digestive juices are being poured into the duodenum. And to make sure that this juice and the bile together enter here at the right time, and not when not needed, uh, this part also secretes those hormonal substances, those chemicals, which ensure that. So you can see that this is the most important, in a way, very, very important part of the small intestine. The juices and all are here. They'll keep acting in the subsequent parts, but the action really has begun here. And it's because of this that the food will eventually get digested and absorbed. So all the preparation has been made in the initial part of the small intestine, which is a C-shaped structure, and the inside of the C uh, accommodates the head of the pancreas, and then there is a tail of the pancreas. So the pancreas not only secretes insulin, which almost everybody is now familiar with, but the pancreas also secretes digestive juices. So it's a two-in-one organ. Now, this is a further magnified view of the uh, intestine, and you can see these two layers of muscles, the longitudinal muscles and the circular muscles. Further outside has not been shown in this picture, but you can see that if we look at this is the side on which we have the cavity, the hollow of the intestine. This is the outside. So in the hollow, if we see it enlarged, we find that there are these finger-like projections called the villi. And it is in these villi that the arteries enter, pick up the food that has been digested, and bring it back in these veins for taking it into the general circulation. And it is in these hollows that we also have these lymphatic vessels into which the digested fat is absorbed. So, and then that is carried again, finally, it enters the bloodstream. So it is here that takes place. And why these finger-like projections? These finger-like projections multiply the surface area. Now here one villus has been shown further enlarged to show the different types of cells which line the hollow, line the intestine towards the hollow end of the intestine. And since it's full of these projections, it's folded up in the form of these finger-like projections. We can see this one projection enlarged, and we find different types of cells, cells which secrete the digestive juices, cells which secrete mucus, which is the lubricant, and cells which secrete the hormones. Hormones are secreted to regulate the uh, secretion of the stomach, the intestines, and also insulin. Because in anticipation of the food actually entering the bloodstream, a signal is sent from here to initiate the insulin secretion to activate the pancreas. And these cells, which are a part of the immune system, a local immune system, the innate immune system, which can take care of many germs by phagocytosis, that primitive mechanism by which the cell eats up the germs. All these form a part of this lining. Now here, a very schematic diagram to show clearly that if that this is the cell which lines the intestine. You know, in this part, this type of a cell through which the food is absorbed. Now you find that towards the this is the hollow and this is the outside, towards the outside. So this is the hollow of the intestine, and the cell is facing this way. Now this cell is for digestion and absorption. Uh, Now you can see that in this cell itself there are folds, further folds. Now these are not the villi. The villus is this whole thing. These folds are in this single cell. At the tip of this single cell are these folds. They not only multiply the surface area further, they are also in these folds, the microvilli, that is small villi. They're called microvilli because they're tiny, minute villi, and cannot be even seen properly under the microscope. They are seen properly only under the electron microscope, not under the ordinary light microscope. Now, these are not only multiplying the surface area, they also have many enzymes for the final stages of digestion. And you can understand why the final stages of digestion have been located here, because if the final digestion takes place right here, then it is at the doorstep. The nutrients which have to get absorbed are already more or less inside the cell, and they just have to be transferred. So the cell does not have to find the finally digested nutrients. The final digestion itself takes place right here. So that is the beauty of these microvilli. So the final stages of digestion will take place here. The food now will be transmitted into the cell, from the cell into the small amount of fluid that separates these cells from the blood vessels or the lymphatics, the lymph vessels, and the nutrient enters the blood from here. So final stages of digestion here, and this is the process of absorption. Now let's start the digestion of the nutrients one by one. Carbohydrates form the backbone of our diet, and quite rightly so. So we start with the carbohydrates, and the most uh, abundant carbohydrate in our diet is starch. And we had seen that the digestion of starch begins in the mouth with salivary amylase. That amylase is the enzyme secreted by the salivary glands. So saliva has amylase, called amylase because it splits amylum, which is another name for starch. So ase, means breaking it down. So amylase breaks down starch, and the process starts in the mouth. But then only a small amount of starch is digested there, which has its function. It makes the food taste sweeter and so on, all those things we saw, because it breaks down starch into maltose, and that maltose is sweet, whereas starch is tasteless. So it gives sweet taste to the food that is being chewed in the mouth. That's one of the things that happens in the mouth while chewing. But then that does not continue in the stomach. The digestion by salivary amylase, which started in the mouth, is terminated in the stomach. It stops in the stomach because the stomach is in the stomach, the environment is acidic. The stomach secretes strong hydrochloric acid. And we saw that is also important because then it kills many germs. So food in a way gets partly purified, cleansed up uh, of the germs by this direct and crude action of the hydrochloric acid on those germs. It just kills them. Uh, so in this acidic environment, this amylase cannot act. So the process of starch digestion, which started in the mouth, is terminated in the stomach. It stops. But then it is resumed in the small intestine, because the pancreatic juice contains amylase, which also, like the salivary amylase, breaks down starch into maltose. Maltose is a disaccharide. Di means two. Saccharide, is anything related to sugar is saccharide, like saccharin. Artificial sugar is also called saccharin. Uh, so maltose is a disaccharide, means made up of two units. Which two units? Each molecule of maltose is made up of two molecules of glucose combined together, joined together chemically. Not just a loose combination, it's a chemical combination which gives us a single molecule of maltose. What is a molecule? Molecule is that smallest particle which retains the properties of the substance. So whatever properties maltose has are there in every maltose molecule. If we try to break maltose further, we get two molecules of glucose, and the properties of this glucose are different from those of maltose. So that's what we mean by a molecule, which means if you have a lump of maltose and you keep breaking it into smaller and smaller bits, and imagine that you can break it into smaller bits than you can easily do in a pestle and mortar, much smaller than that. Finally, you'll reach those little bits of maltose which cannot be even seen with the naked eye. That will be a molecule. And if you further try to break this molecule, it will give us not another still smaller piece of maltose. It will instead give us two bits of glucose. And that is what we need to do for the final digestion, but that does not take place through the action of amylase. Amylase breaks down starch only into maltose, which is a disaccharide, still made up of two units of glucose. Do we have any other disaccharides which have to be digested? Yes, at least two more. One is sucrose, which is ordinary cane sugar. Now, this is made up of 1 unit of glucose and 1 unit of fructose. Fructose is the main sugar present in fruits. So the sugar in fruits is already a monosaccharide. That is, does not need further digestion. But ordinary cane sugar does need digestion. It's a disaccharide. And when it breaks into 1 unit of glucose and 1 unit of fructose. So each molecule of sucrose gives one molecule of glucose, one molecule of fructose. And this takes place through the action of an enzyme in the small intestine. Again, we'll see where. You would have got the hint already that the final stages of digestion take place in the microvilli. So it is here that the disaccharides are digested. And this, uh, if you see it under the ordinary light microscope, you cannot see these individual projections, but you can see small little tiny hairy structures which give the appearance of a brush. So sometimes this border consisting of these microvilli is also called brush border. A much more sort of popular type of a name easy to sort of relate to than microvilli. So microvilli and the brush border essentially mean the same thing. These are the two other disaccharides in the diet, sucrose and lactose. Lactose is the disaccharide present in milk. And you might have heard of lactose intolerance. Lactose intolerance means that the person doesn't have enough lactase, which breaks down lactose, and therefore the person cannot digest milk. Instead, what happens is that the undigested lactose acts like fiber. It gets fermented by bacteria in the large intestine and produces gas, which in turn leads to discomfort and may lead to diarrhea. And some people have this, but then people who have lactose intolerance can still digest curd, because curd means the milk is fermented by germs, uh, and the fermented products, the germs also ferment lactose, and the result is the amount of lactose in curd is much less than in the milk which we started with. And since the amount of lactose is reduced, the person who cannot digest milk can still digest curd or yogurt. So that is about lactose intolerance. Now, who has lactose intolerance? By and large, children don't have it. Very few newborns have lactose intolerance. They can digest mother's milk, cow's milk, and all types of milk. They generally don't have lactose intolerance. But as a person grows older and becomes an adult, many do develop lactose intolerance. And in old age, uh, most people develop at least some amount of lactose intolerance. So it's relative. But then who are the people who are genetically predestined to develop lactose intolerance when they become adults? It seems that there has been a sort of a adjustment between the population and their dietary habits. Populations which habitually consume milk also throughout life in adulthood, as is the common practice in India, generally do not have lactose intolerance. Whereas in countries like Africa, I mean, continents like Africa, in many African countries where milk is consumed only by babies, adults don't consume milk, the prevalence of lactose intolerance is much higher. So it seems depends upon the dietary habits. Whether those people developed those dietary habits because they observed that milk made them intolerant, or they become intolerant because they did not make use of the lactose, make use of the capacity to digest lactose, and therefore this capacity weakened and finally more or less disappeared from them. That is difficult to say. But the fact is that there is a relationship between the dietary habits of a population and lactose intolerance. Those who consume milk habitually, those who have consumed it generation after generation for centuries, they are the people who are unlikely to have lactose intolerance. Now, enzymes for the breakdown of disaccharides are present in the microvilli. So, the final digestion of carbohydrates takes place in the microvilli or the brush border. So, maltose gives us 2 units of glucose, sucrose gives us 1 unit of glucose, one of fructose, and lactose gives us 1 unit of glucose and 1 unit of another sugar, monosaccharide, galactose. Now, glucose, fructose, and galactose are monosaccharides, the single unit sugars. Maltose, sucrose, and lactose are disaccharides, 2 units. Monosaccharides are then absorbed into the blood. So the final digestion, which gives us these monosaccharides, glucose, fructose, and galactose, takes place at the very doorstep of the blood vessels into which these have to be absorbed. So it is here that the final stages of digestion take place right in the border of the intestine, and here enter the blood vessels, which take these final products of digestion away from the intestine. So the blood that leaves the intestine, it is venous blood, uh, blood which has given up some of its food to the intestines, some of its oxygen to the intestine, picked up carbon dioxide from the intestine, as happens everywhere in the body. But one thing unique has happened in the intestines. And that unique thing is that the blood that is leaving the intestines has also picked up the digested food when it happens to be available in the hollow of the intestine. Now we come to the digestion of proteins. The pancreatic juice has enzymes also for protein digestion. So the protein digestion, which started in the stomach with pepsin, which broke it down into smaller units called peptides, that digestion, which started in the stomach, is carried further to the next stage through the action of the protein splitting enzymes of the pancreatic juice. And the products are small peptides, that is, units of amino acids which are smaller than the peptides which we got in the stomach, and some actual amino acids as the final products. The final digestion of uh, proteins should be of proteins is also carried out by enzymes in the microvilli or the brush border. And the final product are the amino acids. And these amino acids are absorbed into the bloodstream. So if this is the food protein, as a result of digestion, it's broken down into amino acids, and these amino acids are absorbed into the blood, and these amino acids may be utilized for manufacturing the proteins of which we are made. And what it means is these amino acids are now reorganized, rearranged in such a way as to give us human protein. Now we come to the digestion of fats. The enzymes for fat digestion are also present in the pancreatic juice, but these fat splitting enzymes also need bile. One thing which I may mention here is that our reserve for fat digestion is much less than for carbohydrate and protein digestion. And therefore, if there's any impairment of digestion, say because of deficiency of pancreatic juice or whatever reason, the uh, first uh, nutrient of which the digestion is affected is fats. And that's why a person who can't digest food properly finds that the amount of fat in the stool goes up. The stools become greasy and they float in the commode. And that's one of the indications that the person is not digesting enough of all the fat that the person is eating. And because the reserve for fat digestion is much less than for carbohydrate and protein digestion. Now, fat digestion by the pancreatic enzymes, lipase and colipase, these are the two enzymes present in the pancreatic juice which digest fat, that also needs bile. The bile is manufactured in the liver, stored in the gallbladder, and then from here transmitted by this tube, conducted by this tube to the small intestine, the initial part, the duodenum, through the same tube which brings the pancreatic juice. Now, what is the function of bile salts? Why do we need bile for digesting fats? Because fats, are not water soluble, but at least they can be made water friendly. No, you might have seen that if you put a small amount of fat into hot water or milk or tea, and then stir it very briskly with a spoon, this fat breaks down into small globules and seems more water friendly, if not water soluble, than a big blob of fat just floating in that liquid. So that is what we call emulsification. Now, bile salts emulsify the fat. And how do they do it? Bile salt, if you look at a bile salt molecule, it basically has two ends, the fat soluble end and the water soluble end. And the result is that apart from breaking down the big fat globules into smaller bits, uh, it can enclose these small bits of fat, small globules of fat like this. There's a fat soluble end or a fat friendly end, uh, which has a high affinity for fat, that faces the fat molecule. And there's a water friendly end, which has that faces the watery environment of the intestine. So they become a sort of a bridge. And because of this water friendly end, now the fat globule itself can now uh, appear to be dissolved in this water. However, one thing that has happened is, as a result of this, one positive thing that has happened is it has been broken down into small bits. So the surface area available for the action of the digestive enzymes has increased. But one thing negative that has happened is that if this fat globule is surrounded entirely by these bile salts like this, uh, it, it is not exposed to the action of the fat splitting enzymes. So how will this fat in this globule be digested? And that is why, apart from the major fat, apart from the enzyme which directly dissolves fat, that is lipase, fats are also called lipids. And therefore, the enzyme that breaks down lipids is lipase. So, along with that lipase, we also have colipase, that is an associated enzyme, an enzyme which needs to accompany lipase for the lipase to be able to work. So it's sort of a partner, a cooperative partner, something which is required along with lipase. That also is there in the pancreatic juice. What colipase does is to change the shape of this globule in such a way that a bit of it gets exposed to lipase. So it can alter its shape in such a way that it's not completely enclosed, but a bit is available for lipase to act. And you can see, I mean, how much engineering there is at a micro level as to be able to carry out this digestion. You have made fat water soluble and broken it up to increase the surface area of the fat available, and also uh, made that arrangement so that the enzyme can get into it in spite of the environment being watery and this fat being water insoluble. So it can enter and digest this. Now, after digestion, fat is absorbed into the lymphatics, not into the bloodstream, because these molecules are too big to get directly into the bloodstream. Uh, and the reserve for fat digestion is much less than for carbohydrate and protein digestion, as we saw. And therefore, if a person has indigestion due to any reasons, and the first thing that happens is that the stools become greasy. Now, in contrast with the usual type of fat that we take, which is triglyceride, which gets digested like this. There are other types of fats which have medium chain, which are medium chain triglycerides. What's the difference? A triglyceride, is a fat molecule which basically is like an E, you know, with three prongs. That's why triglyceride. These three prongs belong to glycerol, which is one of the components. Now, to these three prongs of the E are attached fatty acids. And if these fatty acids have long chains, we call it a long chain triglyceride. If they have medium sized chains, then we call them medium chain triglycerides. Most of the fat in the diet is long chain triglycerides, and it is digested through the process that we just saw. But that process is a little complex, and we saw the reserve is very little. But there are medium chain triglycerides which are much simpler to digest and absorb, and they enter bloodstream instead of the lymphatics. And therefore, a person who cannot digest the normal uh, triglycerides that we take, normal types of fats that we take, can still digest coconut oil because that is rich in these medium chain triglycerides, which are not dependent upon the action of lipase. They can be digested even without the action of lipase. And therefore, if a person gets diarrhea, in which one can get a temporary enzyme deficiency, the person may not be able to digest fat, but still this person will be able to digest coconut oil. Now, the regulatory part. How does the pancreas know when to send its juice into the small intestine? By the simple mechanism of the food entering the duodenum. So, when the food enters the initial part of the small intestine, that is the duodenum has secretes hormones which reach the pancreas and increase the secretion of the pancreatic juice. It also has the hormone which goes to the gallbladder and stimulates contraction of the gallbladder so that bile is released from the gallbladder and reaches the small intestine along with the pancreatic juice. And the economy is such and coordination is such that the same hormones which increase the secretion of the pancreatic juice and induce the contraction of the gallbladder, these same hormones also reduce the secretion of the gastric juice because now the food has started leaving the stomach and started entering the small intestine. So the process of not only the switching on of the pancreatic juice and the bile should start, the process of switching off of the gastric secretion should also begin simultaneously. And that is initiated by the same set of hormones. And why is the final digestion in the brush border? The final digestion is in the brush border because that makes it easier for the final products of digestion to be absorbed because it's happening right at the doorstep of the blood vessels or the lymphatics into which the digested food has to enter. So again, you can see what a well-conceived design we have in the body. Now we look at absorption a little in detail. So far, we have looked at digestion primarily, that is the food getting broken up into small bits, which can be taken up into the bloodstream or the lymphatics. Now, this absorption is increased as a result of an increase in the surface area. If we look at the inside of the small intestine, open up the wall and see it with the naked eye, not under the microscope, still you find that it is not smooth, it is folded. So this is how it looks to the naked eye if you open up the jejunum. Jejunum is immediately after the duodenum. So that part of the small intestine, which can be taken as a sort of a representative of the small intestine where absorption takes place, you find it is folded up like this. And then you have these villi. Uh, so each of these folds will have under the microscope a large number of these folds, the villi, and this villi are lined by these cells, which in turn have the brush border, which further increase the surface area. The brush border increases the surface area still further. So the microvilli not only have the enzymes for the final digestion, they also increase the area available for absorption. This has been shown diagrammatically here. So if you look at the intestine cut across with the naked eye, you find these folds. That increases the surface area 3 times. Then you take one of these folds and see it under the microscope. You find that there are these uh, folds, which are the villi. They increase the surface area tenfold. And then you take up one of these villi and see it under the microscope. You find that each cell lining each villus, the singular is villus, plural is villi. So these cells lining each villus, they further have at these tiny little hair-like structures, the brush border or the microvilli, which increase the surface area further 20-fold. So 3, 10, and 20 together gives 3 multiplied by 10 multiplied by 20. It gives a 600-fold increase in the surface area of the small intestine as compared to what it would have been. It was just one smooth surface for absorption. And then further, you find the intestine itself is 20 feet long. And how? By being folded up, coiled up, it is packed into the abdomen. So that gives us a length of the intestine which is much more than we need. Normally, the absorption is over much before it reaches the very end of the intestine, except that some fat may reach the very end. Much of it is absorbed much before that because we have so much reserve. So these are the microvilli which increase the surface area further 20-fold, giving us a total increase of 600-fold. Now, what happens to the finally digested nutrients which are absorbed into the blood? So this is the blood entering the intestine. It has picked up the finally digested nutrients like glucose and amino acids from the blood, from the intestines. It has picked that up and that has entered this vein. Now this vein does not go straight to the heart like the venous blood from the rest of the body. It first goes to the liver. And in the liver, it breaks down into a set of capillaries across which exchange can take place. Now, this is again a very beautiful arrangement with a great purpose. Although the nutrients are required all over the body, they are not released into the whole body by taking it to the heart. First it passes through the liver. Now, what does the liver do to it? Many things. One of the things that it does is that since there's a big rush of glucose after this, it picks up this glucose and starts converting it into glycogen. So liver becomes a glucose consuming organ so that less glucose would be sent into the general circulation to be handled by the insulin. So some glucose would be picked up by the liver. Secondly, there may be many harmful substances coming from the intestines which have escaped the uh, whatever traps we had in the intestine itself. The mouth had some traps. The stomach had hydrochloric acid. The cells we saw, the intestinal cells we saw have uh, an arrangement for phagocytosis, eating up the cells. In spite of that, if any harmful substances have entered and some germs have entered, the liver can now handle them. So the chemical substances can be removed and detoxified, that is proper detoxification by the liver. And the germs, again, the liver has Kupffer cells. Kupffer cells, are phagocytic cells, which are a part of the innate immunity with which we are born. And they can take care of the germs by eating them up, phagocytosis, by that primitive process. So that the blood then that finally goes and enters the uh, heart, that blood has been purified by through detoxification, through the elimination of many germs, and a reduced amount of glucose enters here because some of the glucose has been converted into glycogen. But it's a temporary storage between meals. Then the liver, instead of remaining a glucose consuming organ, becomes a glucose producing organ. This glycogen is broken down. So it's like a savings bank account uh, with a fast turnover. You keep depositing after every meal and you keep withdrawing between meals. So this is what the liver does. Liver does many other things also. It's an important area of the body. It does many things, but you'd already got some idea of how intimately the liver is involved in the digestive process, not only as as an organ where bile is manufactured for digestion of fats, but a lot else takes place. And to ensure that the liver is able to do it, the digested food is brought first to the liver before it goes anywhere else. However, the fats have a different story. The fats are absorbed into these lymphatics, another set of blood vessels. And these are not really blood vessels. You may ask what lymphatics are. Lymphatics have not only this function, lymphatics are there all over the body. because any part of the body where the artery enters, the along with the oxygen and the food, naturally the fluid also diffuses out. And the arrangement of the pressures is such that the fluid oozes out at the arterial end of the capillary and is taken back at the venous end of the capillary. However, the amount of fluid that is lost at the arterial end is a little more than the amount that is picked up at the venous end. And this excess may also have some proteins, etc., which can't be picked up by the capillary. And all this can be then taken up by the lymphatics. So, lymphatics can absorb bigger molecules than these capillaries can. And that's why they can also absorb fat, which has bigger sized particles. These particles, in the form of which it is absorbed, are chylomicrons. Now, what are chylomicrons? We saw that the final stages of digestion take place in the intestinal wall itself. That is true also of fats. After that, the bile has served its function, it is released, but instead, there are other substances like the phospholipids and cholesterol, which then perform the same function as the bile does in the intestines. And that coats these finally digested fat molecules. And these are called chylomicrons, and that is what is absorbed into the lymphatics to enter into the bloodstream. If you haven't followed all the terms, doesn't matter. The important thing is that the digestion and absorption of fats as compared to other substances is different. The final products of digestion of carbohydrates and proteins enter the bloodstream and pass through the liver. The final products of fat digestion enter the lymphatics and do not pass through the liver. They enter straight the heart with the heart because they don't need further purification. And that also explains why in liver disease, one of the things that happens is that the bacterial load on the body increases, and that in turn increases the formation of antibodies to those, and therefore gamma globulin levels might go up. And on the other hand, another protein in the blood, albumin, is manufactured only in the liver, and therefore the albumin levels go down and globulin levels go up. Globulins, particularly gamma globulins, which are necessary because the liver is not eliminating the germs, and therefore you might have seen in your blood reports in the proteins in the plasma or serum are mentioned total proteins, albumin, and globulin. And in liver disease, albumin goes down because liver is the only place where albumin is manufactured. And globulin levels go up because the germs are not getting eliminated in the liver, and therefore the rest of the immune system in the body is manufacturing antibodies against those, and antibodies are globulins. Therefore, globulin levels go up. And therefore, when they take out the albumin globulin ratio, in the reports generally called the AG ratio, that ratio will change. That ratio will become smaller because albumin levels have fallen and globulin levels have gone up. That's what happens in liver disease. That's one of the things that can happen in liver disease. Now, nutrients that need no digestion. No digestion doesn't mean that nothing happens to them. There are elaborate processes for absorption, but they don't have to be broken down into small bits. So there are elaborate processes for absorption of different vitamins, fat soluble vitamins like A, D, E, and K. They get absorbed differently in association with fats. Water soluble vitamins like vitamin B complex and C, they get absorbed into the bloodstream directly, like other water soluble substances. And uh, vitamin B12 and vitamin A and D, they not only get absorbed, they also get stored in the liver. So there are elaborate mechanisms for digestion absorption of these. In the same way, for minerals like iron, there are elaborate mechanisms to ensure that the amount absorbed has a close relationship to the amount the body actually needs, and so on. So there are, and then for say absorption of calcium is closely linked to the availability of a calcium binding protein in the intestines, which in turn is manufactured with the help of vitamin D, and therefore vitamin D is required for absorption of calcium, and that's how the two get linked up. And in supplements, you find both of these together very often because if a person is calcium deficient, not only the person may need calcium, but also need vitamin D so that more calcium binding protein uh, can be manufactured in the intestine so that this calcium can be absorbed properly. So there are elaborate mechanisms for each, but they need no digestion. Water. So these are the nutrients that do not need digestion. All these are absorbed in the small intestine. Now we come to the large intestine or the colon. It is wanted, but not much. There are people who, because of some diseases like ulcerative colitis, their entire colon might be removed. And still they can live a fairly satisfactory life, hardly finding anything abnormal. In fact, to some extent, this happens because in the colon, a large amount of water is absorbed, and therefore the fluid becomes stool becomes less liquid than it would be if the stool consisted of what came out from the small intestine. But then, if the entire colon is removed, to some extent, the last bit of the small intestine takes over the function of the large intestine through adaptation. Uh, it starts absorbing more water than it normally does, and the result is that this person whose colon has been entirely removed, after a few months, passes a liquid stool compared to the normal person, but not as liquid as it otherwise would have been. So it becomes less liquid because the terminal part of the small intestine starts performing some of the functions of the large intestine. But all the same, since it is possible to live a satisfactory life without the large intestine or the colon, we might say it's wanted but not much. Here the cue comes from uh, what Emerson once said. The American philosopher Ralph Waldo Emerson. He said, "Everybody is needed. Everybody, every human being is needed. Nobody is wanted much." Hmm? So, taking a cue from that. Now, what does the colon get? What is it that reaches the colon? A rather worthless legacy. Much of what we ate has been digested and absorbed by the time it reaches the large intestine. And therefore, it reaches a sort of, it's a worthless legacy that the colon inherits from the small intestine, but works very hard on it, and with some results which are very useful for the body to keep us healthy. So the colon is wanted because it makes important contributions to our health, but not needed much, because if you remove the colon, the person can still live. But all the same, it is needed. Uh, it handles junk, you might say, but the junk dealer is also needed. Huh? So this is our kabadi wala. Very important. Huh? Takes care of all the junk, otherwise we will have it all over, spilled all over. So what enters the largest intestine is undigested food, food which could not be digested. By and large, very little. More than 90% of the food that we eat gets digested. In fact, if you take it at the last stage in the stool, more than 95%, around 97 to 98% of the food that we ate has been digested. So very little undigested food. But whatever is undigested, by the time it reaches the large intestine, may get digested in the large intestine through the action of the germs present there. So undigested food, beside the indigestible food, food which cannot be digested, dietary fiber, particularly cellulose and lignin, these two components of dietary fiber, totally indigestible and not even fermentable much. No, they don't even get fermented. But some components of dietary fiber, like pectin. Pectin, is what you have in, say, apples, which gives the apples a binding force, or water soluble fiber, the type you have in isabgol. That is indigestible, but it can be fermented in the large intestine. So, indigestible food which cannot be digested, and water. These are the main components of what enters the large intestine. Now, what happens in the large intestine? The inside of the large intestine is dark and moist. It is neither too acidic nor alkaline, and food stays there a long time. Compared to the stomach and the small intestine, it spends a very long time in the large intestine. For all the hard work that the large intestine has to do, it needs time. So maximum time, in fact, is spent in the large intestine before we get rid of what we have eaten. And now these conditions, a dark and moist environment, which is neither too acidic nor alkaline, where food is available for a long period, which means food stagnates, these are ideal conditions for bacterial growth. So we have a large population of germs in the intestines, much of it in the large intestine. Tomorrow, Dr. Mankul Goel will talk in much greater detail about the contribution that these bacteria make to our staying healthy. So, what happens in the large intestine is water is absorbed. Not more than what happens in the small intestine, much less than that, but enough to make a difference to the consistency of this stool, the whatever remains. You might say we take only 1.5 liters of water. Can't the small intestine absorb all that? But the small intestine has to absorb not that 1.5 liter of water. It has to absorb another 10 liters of water, which has been poured into the stomach and intestines because of the digestive juices. So digestive juices and the bile together have about 10 liters of water. So what the intestines have to absorb is more than 10 liters of water, not just the 1 or 1.5 liter that we drink. And much of it is absorbed in the small intestine, but the last bit that enters the large intestine, quite a bit of it is absorbed in the large intestine. Say 1 liter or so gets absorbed in the large intestine. Along with that, salts, sodium, potassium, and so on, they can also be absorbed. And this absorption is not blind, it is regulated. It is regulated by a hormone from the adrenal cortex, the aldosterone, which can regulate how much salt, how much of sodium will absorb, how much potassium will absorb or release into the colon, how much sodium will absorb, how much potassium will absorb. All that is regulated by the hormone. So regulated absorption of salts and absorption of some products of fermentation. What are the products of fermentation? Some volatile fatty acids and gases. Again, what contribution these make, these volatile fatty acids, to our health? Again, Dr. Mankul Goyal, I'm sure, will talk in much greater detail tomorrow. But some of them provide nourishment, which means a little more nourishment can be extracted from the food that reach the large intestine. Some of these volatile fatty acids uh, all sort of affect the cell cycle in the large intestine, which means that they reduce the possibility of cancer developing there. And the type of volatile fatty acids formed on different diets are different. And they also change, this fermentation also changes the bile salts, which came from the, which could not be absorbed in the small intestine. Some of them release the large intestine. So they are also fermented. And after fermentation, the bile salts, some of these will get into the stool and some of them get absorbed and reach the liver again. So the bile salts keep getting absorbed from the intestines, reach the liver again, and for recycled. So the bile salts are not wasted, they are being recycled. And so we do not need a fresh synthesis of all the bile salts. Quite a bit of it is being recycled. But then the type of bile salts that are produced as a result of this fermentation are also different on different diets. And then if protein is digested, that also releases one of the gases, it releases ammonia. And this gas, these gases, again, some of these would be absorbed and be lost in the breath. That's how you may get a smelly breath on certain foods. But much of these gases are released as flatus. So having some flatus is completely normal and physiological. It is the excess that creates problems. And those who have this problem of excessive flatulence, they can reduce it by avoiding the foods which remain undigested in their intestines and reach the large intestine for fermentation. So those who are more prone to this type of a problem should reduce those foods which have more components which are likely to reach the large intestine. And these classically are the beans, particularly the beans, the whole beans like kidney beans and so on, rajma and chana and the Bengal gram. These are the types of horse gram. These are the type of kala chana. So these are the type of foods that are likely to reach the large intestine, some of it, and some components of these then get fermented to give us these gases. So all this is also has a function. And some of these germs manufacture vitamins which we can use. So the vitamins we can use, the little bit of nourishment from the fatty acids that they make for the intestine itself and for the body, and protection against cancer. All these are things which are uh, so the bacteria reside in our germ not through a process of a peaceful coexistence. In fact, it is a mutually beneficial relationship. It's not just coexisting in peacefully and the needs of both being met. Both the bacterial population and we are meeting the needs of one another. So not only we are making food available to the germs are also doing a lot of service to us by being there. All this Dr. Mankul Goyal will talk much more about tomorrow. Now we come to the final exit of whatever is still left at the end of the large intestine in the rectum, the process of defecation. Now, defecation is essentially a reflex, and the reflex is stimulated by pressure in the rectum. So, when enough has accumulated in the rectum, it's the pressure generated which stimulates the reflex. And the reflex can be stimulated also by eating or drinking. And sometimes, therefore, you find that immediately after eating or drinking, one feels like going to the toilet to pass stool. This is called the gastrocolic reflex. But by and large, the normal route by which the reflex is stimulated is by accumulation of enough content in the rectum for the pressure to be generated. Now, this reflex, what happens in the reflex is it stimulates contraction of part of the colon. Now, why this part of that has been highlighted? Not the entire colon, the last bit, the descending colon and the sigmoid colon, not the transverse and the ascending colons. So, part of the colon. And of course, the whole of the rectum and the anal canal. Now, why this is important, we shall come to in a moment. Why this part, remember that only part of the colon is emptied, not the whole of it. Why that is important. So, the reflex stimulates contraction of part of the colon, the whole of the rectum and the anal canal. And then for it to be able to go out, it is associated with relaxation of the external sphincter and the internal sphincter. Now, sphincters are ring-like structures which guard an opening. These are muscular. They can contract or relax. When they contract, the opening is closed. When they relax, the opening is open. There's an internal sphincter that is in the wall of the anal canal itself at the very end. Now, this is involuntary, which means that uh, it remains contracted except during the defecation reflex, and this takes place on its own. We don't have to do anything. We can't control it through our willpower. But however, the external sphincter is outside the intestines. It is just under the skin, and we can feel it. And we also know that this is under voluntary control. This has the type of muscles which are under voluntary control. And the result is that to some extent, we can contract this sphincter, we can contract it to hold the stool. If the opportunity is not available and we are feeling like going, to some extent we can hold because of the external sphincter. But during the relaxation, during the defecation reflex, both are relaxed with the result that we can pass the stool. But then we do not have the basic defecation reflex exactly as shown here. It's not that whenever we feel pressure in the rectum, we go to pass the stool. In human beings, we have learned to regulate it better, which means we have modified it. You can modify the reflex by conditioning, which means that you condition yourself to certain circumstances in which this reflex is likely to be stimulated, provided there's enough material in the rectum. Now, how do we modify it? We modify it in childhood through toilet training. And essentially, what does toilet training of a baby consist of? You are helping the baby build up an association with certain things and passing of the stool. You're making the baby associated with a certain time. This is something which has to happen in the morning, for example, particularly in India. This is a morning activity. So you're making the child build up an association with this activity, with the morning, with the place. It has to be done not elsewhere except in the toilet, the place, the atmosphere, a relaxed and peaceful atmosphere, a secure atmosphere. Imagine the time is right, the place is right, it is the toilet, uh, and the person is feeling like passing the stool. Everything is right, but the person is not secure. Yeah? There is no door into the toilet, or you are afraid anybody might enter, that you can't bolt the door from inside. You will not be able to pass the stool easily. So, the right atmosphere, a peaceful and secure atmosphere. So, you're helping the child pick up that this is an activity which has to be done at a particular time, at a fixed place, and in a peaceful and secure atmosphere. So, that is what toilet training is. And within a few months, you are able to train a baby properly so that the baby does not dirty the diapers anymore and is able to follow this routine. So that is toilet training. But then as we grow up, uh, we develop other habits, and we sometimes couple this reflex with other activities. Particularly if the person is constipated, the person finds that certain other associations may help, and one of those can be reading. Some people can't pass a stool unless they're also smoking, which is not good. Smoking is not good. Reading is quite good. Yeah. Can associate with the reading. And in fact, I have finished several books by reading 2 or 3 pages a day. And the only disadvantage is that sometimes you get absorbed in the reading. The basic job for which you entered is over, but because you want to reach a certain point in the reading and finish a certain page or something, you go on sitting there, without even realizing why you are sitting there anymore. In fact, it makes it a very relaxed activity. You are there, it's happening on its own. You're not bothered, and at the same time, you are reading something. So it's a very effortless, stress-free way of passing the stool, uh, and I found it very useful. I'm sure many others also do. Uh, I know of many others who also do. And of course, it needs a relaxed mind. Everything may be right, the time may be right, the place may be right, the atmosphere may be peaceful and secure, but it's not only the peace outside, it is also the peace within which is important to be able to pass the stool. So this is sort of the way the basic reflex gets modified in human beings. And if something is wrong, a person get constipated, which means the stools are not only passed less frequently, the stools also become hard and therefore become difficult to pass. And therefore it becomes a vicious cycle. Uh, the harder the stool, the more difficult it is to pass. And the more difficult it is to pass, the longer the delay. And the result is that the person is constipated. Constipation is not just an inconvenience, it's not just an uncomfortable, painful process, it also has serious sequelae. Because if a person has constipation, the person exerts a lot, tries to increase the pressure in the rectum artificially by squeezing on it through the abdominal muscles. And the result is an obstruction to the blood flow from the legs and the rectum towards the upwards. So, since the flow of blood from the legs is obstructed because of the higher pressure in the abdomen, the blood can't move further up. One can develop varicose veins because the blood gets squeezed in the large intestine. It can't go up because of the pressure generated. Particularly, this happens in the rectum and the anal canal. The person can develop piles. So, varicose veins and piles are two serious sequelae of chronic constipation. How do we treat chronic constipation? With high fiber foods. Uh, High fiber means whole grains and fruits and vegetables. Both provide two different types of fiber. The whole grains provide what we call water insoluble fiber, which by and large cannot be also fermented in the large intestine, and therefore it stays and therefore it contributes to the bulk of the stool. Water soluble fiber, which we have in fruits and vegetables more than others, to some extent also in beans, this water soluble fiber gets fermented. It gets fermented by the germs in the large intestine, and the result, you might say, would be that this fiber is now digested, so it's not contributing, but still it does because it can contribute to bacterial growth, and these bacteria also retain water, and therefore, and some of the water soluble fiber itself retains water, and therefore it increases the softness of the stool and also contributes to the bulk. In fact, the bacterial population forms about 50% of the bulk of the stool, and therefore this water soluble fiber, which stimulates the growth of bacteria, the growth of the germs, also contributes to the bulk of the stool, not only because the germs have a bulk, these germs also are associated with holding water, and they form half the germs contribute about 50% to the uh, bulk of the stool. And therefore, both water soluble fiber and insoluble fiber contribute to the bulking of the stool in different ways. And of course, water insoluble fiber also has metabolic effects like reducing blood cholesterol, helping us with blood sugar levels, and so on. So, therefore, both types of fiber are required, and therefore, we should take both whole grains and also fruits and vegetables for this. But if a person still finds this is not enough, then one can take just the fiber itself in the form of what is called isabgol commonly, but technically ispagula husk. And if you soak it in water for some time, you find it swells up because it holds water. And that is what happens to it also in the intestines. And that is how it can contribute to the bulk which finally reaches the large intestine. This is largely water soluble fiber, but then, as we saw, water soluble fiber, which gets fermented by the germs, can also contribute in an important way to the bulk of the stool. So, this is isabgol. Many types of fancy formulations of isabgol are also available, which form a palatable drink and so on. But at least they are no better than the good old crude husk, which is commonly available in India as a telephone brand. You know, and that is probably the most common brand of the old-fashioned crude Ispagola husk. The more fancy brands in which it is more finely ground and flavored and sweetened and so on to make a palatable drink out of it, one can't be very sure it's equally effective. Certainly, it's not more effective. Why one can't be sure whether it's even equally effective is because part of the action of the fiber is physical in nature and depends upon the particle size. And therefore, whether those small particles will be able to hold water to the same extent and therefore contribute to the bulking effect of fiber to the same extent is doubtful. And therefore, the good old crude Ispagola husk is probably still the best, provided one is taking it for a purpose and as a not to indulge into another sensory pleasure. Then the relaxed mind. The person should have a relaxed mind passing the stool, as we saw, very important. Everything may be right, but if the person doesn't have peace within, it will be difficult to pass the stool. One can increase the water intake if necessary. It's not that too much water will necessarily relieve constipation, but if the person becomes conscious that probably I'm not taking enough water, and just as we forego the necessary amount of sleep, very often when we remain very busy, we also forego the necessary amount of water, especially in winters when you hardly feel thirsty. But still, we do need a certain amount of water. And therefore, in winters, constipation is more likely, partly because we take less water, less than even is necessary, even in winters, and partly because at low temperatures, all bodily activities go down, and therefore, intestinal motility can also be affected because although the blood temperature is regulated, but still the intestines are sufficiently close to the outer environment to get a little cooled by the cold outside, and the muscles become less active at that low temperature. So, uh, in winters, constipation becomes more. So increase the water intake if necessary. Then regular physical activity helps, particularly yogic postures that move the abdomen. So in whichever there's a bending of the abdomen, squeezing of the abdomen, of course, the simple practices of that type are practices like Pavan Muktasan, which releases not only wind but also applies pressure on the contents of the entire intestines, Pavan Muktasan, or uh, more violent movements are movements like Noli, which sort of churn the entire abdominal content, but more difficult and uh, a little advanced practice. So, yogic postures that move the abdomen can be helpful. Then one can take some warm water or some other warm drink before going to pass the motion. And this, you can understand, helps through the gastrocolic reflex. There's a reflex which can happen soon after we have eaten or taken something straight from the stomach. It hap- has its effect on the colon, bypasses the small intestine. So something entering the stomach itself stimulates the movement of the large intestine and may help us pass the stool. And some people, through conditioning, also develop an association with this warm water and or a warm drink and passing the stool. So just as they are conditioned to other things, this can be also add to that conditioning, and they will not pass the stool unless they have taken something warm like this. This, in a way, is helpful because throughout the night, what has happened is that the person has taken no water. Just before going to bed, also, we avoid taking water so that we don't have to get up in the middle of the night to go to the toilet to pass urine. So, in a way, the kidneys have had to use to the maximum their concentrating ability. The kidneys have been uh, compelled to concentrate the urine as much as possible. And a concentrated urine is not a healthy urine. We shall see that in the next class on probably on Friday when we talk about the kidneys in detail. But a concentrated urine, a yellow urine, is less safe than a dilute whitish urine. And since at night, because of or a long period of sleep, the kidneys have been compelled to concentrate the urine. In the morning, if we take a glass or two of water, it helps in flushing out the kidneys, because then it will give us, uh, right in the morning, this has been taken care of and you've flushed out the kidneys. The kidneys have once again started making dilute urine, and whatever damage could have been done by the concentrated urine overnight, that is undone by this water. But certainly that does not mean that one should get obsessed and feel that something is good, more will be necessarily better. And some people feel that 8 glasses of water is a must every morning. That is not true. It's not there anywhere in Ayurveda. At least Ayurvedic wisdom does not tell us. Why I'm saying that is because there are also, these days on the internet, anybody can put anything. And there are people who have put things like this, that Vagbhat, who is one of the writers of one of the classics on Ayurveda, Vagbhat has said that you should take 8 glasses of water early in the morning. Why drag poor Vagbhat in? Poor Vagbhat never said that. But they just to increase their authority, anybody thinks that just say anything and get away with it. So that type of things are happening. So 8 glasses of water is not rare anywhere in Ayurveda. Okay. So 1 glass, 2 glasses, whatever you feel like taking and take comfortably, take that much. It will help perhaps in passing the stool. It will also help in flushing the kidneys, but certainly not necessarily 8 glasses. And finally, avoid laxatives. And why avoid laxatives? We shall talk in a little detail now. We saw that while passing the stool, not the whole colon, only a part of the colon, the last part of the colon, the descending the sigmoid, the rectum, that is the part that is emptied. What does a laxative do? A laxative moves the whole large intestine so that the whole of it is emptied, and the person feels, oh, today I had a big stool. After so many days, now I'm completely relieved. But then what happens over the next 2 days is that he doesn't pass the stool. Why? Not because he's constipated, but because it is the initial part of the large intestine that is getting filled up. So till the last bit has got filled up, he will not feel like passing the stool. So if you leave it for 3 days, then finally it will reach also the last part of the large intestine. There will be pressure built up in the rectum. He'll feel like passing the stool. But he can't wait these 3 days because he thinks, I'm truly very badly constipated. See, I took a laxative, I passed the stool. Now for the last 3 days, I'm not passed a stool. I'm truly constipated. I need another dose of the laxative. Another dose of the laxative means whatever had filled up, again it gets emptied. So you need another 3 days to fill it up again. So therefore, it becomes habit forming. And that is why it should not be taken. So take something gentle like isabgol, which will not stimulate the intestine so hard as to empty the whole of the large intestine. We are not meant to empty the whole of it because something is happening in the intestine. That is why the food is staying there that long. It is staying there that long because that is the time it needs to absorb water, and for all the other things that we were talking about happen in the large intestine. For that, time is needed, and that is why it's staying that long there. And in the morning, we are emptying only a small part of it. Hardly just about 1/3 of the large intestine is what we are emptying. And therefore, do other things which are important for constipation. Most important being, uh, don't be under stress. If constipation itself causes stress, oh, I'm really badly constipated. Huh? Because some of us get obsessed with the stool. We feel that unless we have passed the stool in the morning, the day can't pass properly. The morning didn't begin well. The day hasn't begun well if I couldn't pass the stool. Now, if you're that obsessed with it, that causes stress. Stress makes it difficult to pass the stool. Difficulty in passing the stool makes the person gets the person more under stress. One more reason gets added to whatever other stresses he has. I have not passed the stool. That becomes an additional reason for the stress. More the stress, more difficult to pass the stool. More difficult to pass the stool, the more stress the person has. So it becomes a vicious cycle. Hmm? So be relaxed. Heavens are not falling. The world is not coming to an end. If one day you did not pass it, you will pass it the next day. After all, where can it go? Jayega kahan? Ek din to niklega hi. Huh? So don't get worried. I'm not saying that you should not worry at all about constipation. Constipation has important sequelae, as we saw, like varicose veins and piles. But once in a while, for a day, if you have not passed it, nothing will happen. Stay relaxed. Forget about it the whole day. Don't keep thinking about the whole day. Don't think about it till the next morning when you actually have to go to the toilet in terms of your routine. At the most, what you can do is the day you're not past it, that day take 1 spoon of isabgol. A little more guarantee that the next day you will pass it. But don't keep thinking about it. Don't worry about it. The world is not come to an end. Nothing will happen if you have not passed this tool occasionally, because sometimes due to various reasons, including the fact that certain days our diet might have been low in fiber, you might have eaten very little food. That itself can be a reason why very little additional material got added to the large intestine. So if you've eaten very little or eaten a low fiber food on a certain day, the next day you may not pass it. Doesn't matter. Next day, to make up for it, just take 1 spoon of isabgol in the morning or anytime you remember to take it, and don't keep thinking about it. So why that is the way to handle it, rather than take laxatives. Laxatives have an inbuilt capacity for getting you under stress if you do not understand the process, because laxative will empty the whole of the large intestine, and the next 2 or 3 days you will not pass the stool because the intestine is getting filled up. The material has still not reached the last bit of the large intestine. So that is what you have to understand, and instead of taking laxatives. Now, one of the most difficult problems of problems that a gastrointestinal specialist faces is to treat people with irritable bowel. In a way, difficult, in a way, good, because gastroenterologists thrive primarily on two problems. One is gastritis, and the other is irritable bowel. One at the beginning of the gastrointestinal tract, another towards the end of the gastrointestinal tract. These two ends are affected, and gastroenterologists thrive on those two. In fact, the single largest category of patients who come to a gastroenterologist have what is called an irritable bowel syndrome, IBS. Syndrome, is a collection of symptoms, and sometimes called irritable bowel, sometimes irritable bowel syndrome, sometimes just irritable colon. But anyway, essentially, these are synonymous. What does this patient have? This patient has alternating constipation and diarrhea. Sometimes the patient complains of constipation, sometimes diarrhea. The two keep alternating. But within that, there are patterns in individuals. Some individuals have irritable bowel of the constipation predominant type. Most of the time, they are constipated rather than have diarrhea. And some have the diarrhea predominant type of irritable bowel. Some are most of the time in diarrhea, occasionally constipated. One thing which is common to most of the patients with irritable bowel is they have a feeling of incomplete evacuation. Even when they pass the stool, they feel no, not enough has been passed. They don't feel that, get that typical feeling of relaxation, which is difficult to describe when one has passed the stool completely and knows, yes, now it's over, I can get up. That feeling of relaxation never comes. So they have a feeling of incomplete evacuation. And what is the treatment? Ispagula husk or isabgol helps these people also. Helps both constipation predominant, diarrhea predominant, whether they are in the constipation phase or in the diarrheal phase. In both phases, it helps, because isabgol doesn't just stimulate the intestine, it is also motility regulator. So in diarrhea, it will reduce the motility. In constipation, it increases the motility. So for both, it is good. So this can be taken. Then in total lifestyle modification, because it is basically a lifestyle disease. We talk more about lifestyle in the next module, yes, 0.04. But basically, all those things which we are familiar with: diet, physical activity, yogic physical activity is better than other physical activities, adequate sleep at the right time, a good diet taken in the right amount, in the right way, uh, no smoking, no drinking, and above all, psychological factors, take care of mental stress. So the most important part of the treatment of irritable bowel is addressing the underlying psychological factors. So we have reached the end of the journey. We started with the mouth the other day, and today we have seen the final exit of what still remains of all that we eat. And what an efficient process we have. If you measure the energy content of the food and the energy content of the stool, hardly 2% of it you discover it in the stool. 98% has been used up by us. That's the miracle that the gastrointestinal tract performs in an assembly line like fashion. Step by step, bit by bit, takes care of everything. Finally, hardly anything is left to throw out. But what we throw out is also important, and that's what we saw towards the end of the journey of the food. Suggested reading the same book, The Human Machine, How to Prevent Breakdowns. And these two textbooks, Fundamentals of Physiology and Understanding Medical Physiology. Sri Aurobindo Ashram Delhi branch, the place from where I'm speaking and the place where I live and work, in the place which is open to all of you anytime. And for any questions or comments, you may drop an email to yes@yesspirituality.com. Gratitude to the Mother and Sri Aurobindo for making these sessions possible. And thank you all for being there.
End our session today, and thank you everyone. Much gratitude.